All right, let's do an example of where we're going to apply the formula. So this is going to give us the total interest rate. Okay, so suppose that an employee working for a state college puts aside $150 at the end of each month in a tax-sheltered annuity. The annuity pays 6% annual interest rate compounded monthly. That makes sense since it's monthly deposits. Suppose that the employee begins contributing at 28. How much will the annuity be worth by the time the employee reaches 62? That's part A. So how much will the annuity be worth by the time the employee reaches 62? So if the person's 28, right? So we got a $150 monthly deposit at a 6% interest rate. Okay, so let's break this down. So the monthly payment, so P is the monthly, in this case, monthly deposits, but in this case, remember, this is regular deposits over time. So P is the principal deposit, in this case, regular deposits, and then it's going to be $150 per month. And then since it's monthly, compounded monthly, right, if it's monthly deposits, should be monthly compounding. So in that case, N is equal to 12 because there's 12 compounds per year, okay? And then the interest rate, R, is equal to what? 0.06. We got to write it as a decimal. Don't write it as a percentage, okay? 6% interest rate translates to 0.06 when we're using the formula. And his age is 28. So that means how much time, so for part A, we need to know T. How much time? So 62, right? So that'll be 34 years. So T is equal to 34 years. So now, what we want to do is we've got all the information that we need to answer part A. So how much will the annuity be worth? Well, we need to use the formula. So the formula equals, remember, it's going to be P times what? The quantity 1 plus R divided by N raised to the what? N times T power minus 1, all divided by R divided by N. So now all we have to do is plug in our values. So that's going to be what? 150 times 1 plus 0.06 over 12. Oops. Raised to the 12 times 34 power minus 1, all divided by 0.06 over 12. Now at this point, guys, it's just plug and chug, right? So you just got to be careful when you're using your calculator. Okay? So use parentheses wherever possible. So I would, or you could calculate the top part first and then divide by this, but use parentheses to make sure that your calculator is doing the order of operations correctly. Okay? It's very easy to make a mistake when students are entering this in your calculator because you don't use parentheses when you should, okay? Or you work from you work through with the numerator first and work from the center out. So calculate this and leave it in your calculator, then raise it to this power, right? And then leave that in your calculator, subtract 1, and then leave that in your calculator, and then multiply it by 150, leave that answer in your calculator, and then divide by this fraction here, okay? So the answer is going to be what? Now, again, we might want to round to the nearest dollar. So in this case here, the final answer is 199,548. I would round up to 549. Right, 549? Let me double check. Yeah, 549. It actually turned out to be 199,548.5, so 50 cents, but I just rounded up to the nearest dollar. Now again, if it's a problem you're working on, make sure you pay attention to the instructions. The instructions may tell you what's the exact amount. The instructions might say round to the nearest dollar, okay? So just pay attention and do your rounding appropriately based on the instructions. Now, part B says, part B says what? Part B says, how much interest will have been earned? Ooh, that's a great question. So we've got to come up with the total of payments, right? The total, or not payments, but the total of deposits. So in this case here, for part B, what we need is we need to know how many total deposits of principal did the person do. So it's 150 every month. How many months did the person make the deposits? Well, 12 times 34. And so if we multiply those together, what do we get? We get so that's 15,300. That one I'm not going to do in my head. I don't have time. You don't have time. Okay, so 61,200. 61,200. That's how much in deposits of your own money or this person's own money that they deposited into the account over the last 34 years. Now, this is the amount, this is the future value. This is the amount that was in the account at the end of the 34 years. This is the amount he contributed. So how much of that is interest? Well, we're just going to subtract off the 61,200. And so that means there's leftover of what? 100 and, so that'd be 138,349, right? So over the last 34 years, he earned that much interest. All right, that's it. Have a great day.